Hello everyone, welcome back to LeetCode Daily Live, where I do the daily question, raw and uncut. So we have a hack today. It's called maximize the number of target nodes after connecting trees to. So this is actually an extension question from yesterday. And yeah, so we are given again two trees, I think. Yeah, we are given two undirected trees again. And this time, so this time the size changed. So it has changed to 100 million, but I think the rest are the same. So these are basically like edges list that represents the tree. So yeah, that's what it describes in this paragraph, I think. So node U is a target to node phi if the number of edges on the path from U to phi is even. Okay, so compared to yesterday, yesterday they want the target to basically like have a length k or less path, but this time it will be even. So note that a node is always target to itself. Yes, because it will be even. Return an array of n integers, answer, where answer I is the maximum possible number of nodes that are target to node I of the first tree. If you have to connect one node from the first tree to another node in the second tree. So again, we basically have two trees, and we're drawing a line over to basically we're drawing a line to like any of these nodes to basically try to maximize our number of targets. And the queries are still independent. So yeah, let's just look at one example. So here we have a tree here, right? Like we have two trees here. And so for I is equal to 0, we want to connect node 0 from node 0 here. And so basically, like if we connect like this node and this node, then we will have 1, 2, 3. Well, these are counted because like they're linked to from 0, right? So 1, 2, 3, and then so this would be like depth 1. So 4, 5, 6, 7, 8. Yeah, so we have 8 nodes that has an even depth if we BFS out from 0. Yeah, so actually this I think like I understand the question now. A big part of it is because it is very similar from yesterday's question, like in terms of the description. But so the difficulty for today is that we actually have to find a quicker way to so for yesterday, basically what we did is we BFS'd from every node because we can, like because we only have 1,000 nodes on each tree to find the number of targets for each node, right? But today we can't do that anymore because our tree 2 and also our tree 1, like they both have 100,000 they both have 100,000 elements now. So yeah, so that's something we have to consider. But there's a change on the definition of a target, which is right now is only even. So that really makes me think that we have to do some sort of DP or like some partitioning. So my theory is if 0 is even, like if 0 is even and you mark 1 as odd and you mark like 2 as odd and 3 as even, 4 as even, if you do that, I think what that will do is it like you basically create a partition that's what I think, which I think it makes sense. So let's get to the drawing board. So the reason I came up with this idea is so let's say you have like some trees, right? So let's just draw up like whatever tree they have there, and maybe I can draw up like a bit more, something like this. So my suggestion is that for each layer, so for this layer, if we call this like the even layer, this would be the odd layer, even layer and odd layer. So how do we know that the even layers are all targets of each other? Yeah, and another observation is that if one node is a target of another node, that node is also being targeted by the node, right? Well, yeah, because like they share the same path. But my idea is basically every time you move, you go up or down a a level, and that will change. Well, and also that changes the length of the path you take, right? So for example, like if we go from like if we want to go from like 6 to 5, right? So we take one step, we turn from even to odd to even to odd to and even to odd. So I think like by doing a partition like that, we can know exactly, well, which node has like which node are targets of like what other nodes. So like all we have to do is like find an arbitrary node. So like let's say 0, and then like we mark the layers, and I think like just by doing that we should be able to solve the question. For in terms of tree to like where we connect our well like where we draw the line like towards the other side. Well, when we draw the line, so let's say we draw from let's say we draw another tree here, right? Something like this, let's say. So if we draw a line here, well, this is going to be odd, right? So we would have turned this into odd. So basically what that means is that well actually like if I draw a bit more, well, we know that the odds are like targets of each other, right? And then you have like the evens. Why is my pen not working? Okay, there we go. So you know that those are evens. Like if we draw a line there. So I think like what we want to do is, well, again, for tree 2, we can partition into like odd and evens, right? But instead of going for the let me draw one more. Like to explain my idea. So instead of choosing like the partition, so like we have the odd and even partition on tree 2 as well, right? So instead of choosing the larger partition, we actually want to pick the smaller one, because we want like ideally we want to like we want to pick even here, right? Because like the even partition is more nodes. But by connecting to an odd like to the other partition and taking one move, we will have all the even partitions nodes instead. And again, I think like if we look at this example, again, it is just trying to throw you off. So it has node 0, like node 4, node 7. But if you look at this, so 0, 4, and 7, they all have the same partition. Like they're all in the same partition. If 0 is in the even partition, well, 7 is like linked 2 apart. 4 is also linked 2 apart. So they are basically the same. Like if I connect 0 to 7, well, it's also like going to give me like 2, 3, and like 1, 5, 6. Like it's gonna give me those nodes, same as like if I choose 0, right? So again, we just have to like use partition on tree 2 as well. So yeah, actually that's how we're gonna solve this question, and we're gonna start coding now. So what do we need? Well, again, I think what we definitely need is an adjacent list. So we have adjacent list 1, adjacent list 2. Maybe I'll make them 2 lines because it might be a bit too long. So yeah, again, we have to find out how many nodes are there. Oh wait, how did I did it yesterday? Okay, the way I did it yesterday is I used a default dict. So let's just do that again. And then like it would be a list. So from collections, import default dict. Yeah. So basically, what we have is we have the node, and then we have a list of children. But we are not given like the maximum amount of nodes on both sides. So that's why like using a default dict will make it a tiny bit easier to implement. Like because we don't have to actually find out like how many nodes are there. Well, I guess it's not too hard, but this looks a tiny bit cleaner. Let's just say that. Um, so yeah, what we want to do is we want to create our adjacent list. So adjacent list 1A, append B, and because it is undirected, we have to do the other way as well. And then so we can basically just copy this edges to adjacent list 2. So now we have the 2 adjacent list. I think what we want to do is we want to have so odd 1, even 1 equals 0, 0. So that's going to be our partition. So partition tree 1 into odd and even. And yeah, so basically how we can do this is we can just do a very simple BFS. So let's try to remember how we did a BFS yesterday. Yeah, and also are we guaranteed that there is a tree? Yes, we guarantee we have at least 2 nodes in each tree. So, and also like there are number from 0 to like whatever the maximum is. So we are always safe to like start from 0. So like I'll start from 0 and then while q yeah, so we don't even have to check the depth this time. We just have to like do that. So we have new q and then at the end make sure to put our new q like into q. So new q is equal to that, and then basically what we want to do, oh yeah, we also have to keep track of whether like we are on the even layer or the odd layer right now. So it's even, we'll make that true for now. So yeah, so we want to get every node from Q, right? So for node in Q, I guess like I guess this works. But like I was thinking of doing while Q and just Q dot pop. But I think this also works. So let's not be too fussy about this. Yeah, of course we also need the scene array, so we don't go back into a node that we have seen already. So if node in scene, well, we just want to continue. We don't want to deal with that again. And then the next thing we want to do is we want to get all the children in the node. So adjacent list 1 node. So that's how we get all the that's how we get all the child, like the children. So again, we just want to check whether we have seen that child yet. If we haven't seen it, let's also add the node here. So if we haven't seen the child yet, we want to add that into our new queue. So that would be like what we have on our next depth, right? So new queue is going to be equal. Well, actually not equal. We just append child like this. But how do we actually know which node falls into like odd or even? Well, what we can do is we can just do yeah, so we can just add the number of nodes in queue, right? So like for example, like for depth 0, we have like just 0 in queue. For depth 1, we are gonna have like 1 and 2 because like 0 will have gotten those stuff. And then for depth 2, we're gonna have 3 and 4. So like we just get the length of queue, and like we will know that. But again, we have to check whether like it is even right now. Like we're on an even layer right now. So if it is, then like we want to add it to the even partition. Otherwise, we'll add it to the odd partition, and then like we'll switch the is even flag. Yeah, so that's basically what we have to do on. Oh, actually, for tree 1, because like for our answer array, we want to return for each of them what is the maximum amount of target, right? So we actually need to know like what is the partition for each node? So actually we need something like is node even, and then I guess what we can do is we can just have a map. So this would be node and then a boolean. Yeah. So like this will just check whether the node is even or not. Yeah, I guess like what that means is we also have to deal with that in here. So of course we want to set 0 to be true. And then so yeah, so because like where switch is even up here, before we append the child, what we can do is we can just actually, what can we do here? Yeah, I think what we can do is we can just set is not even child to be equal to is even. Yeah, I think that should work. So I think now we have done everything for the first tree. So we want to deal with the second tree now. So again, we have like odd second tree and then even second tree. I think we can just make use of most of these code again. So I'm just going to copy this. And then like again we have Q, so let's actually have a comment. So so partition second tree is even, and then like we just basically want to do the same thing here. So I think this code, yeah, we just have to like change all of these, and then scene, yeah, it should be the same. Like we just have to reset that, and yeah, I think that's all we need for like the two trees. I guess what we can do is we can just print out the answer for now to make sure we are still on track. So even 1 or 2 even 2, and then I guess I want to see whether the partition thing is correct or not. So let's print that as well, and then we'll just return a list for now. Okay, so we have 2 3 and 2 3. So does that seem correct? Yes, we have 2 odds here, and then we have 2 evens. Actually, yeah, let's just make sure this is correct as well. So 0 is true. Yeah, okay. I forgot to change something up here, and yeah, I'm still doing the first tree here, so that's why like they have the same answer. But yeah, okay, I think we're on track. So what we want to do next is for each node, so we have our answer array, and then of course at the end we want to return the answer. So we just want to do for I in range. We want to loop through all the keys of tree 1. So that's how we can get it. Dot keys. But then we want it to be sorted. Again, just like yesterday, there's definitely a better way of doing this, but I'm just gonna go with this, like because this is n log n, so it's a bit slower, but I'm not too fussed about it. Like a better way would just be using max, which I can actually do that. So let's just do that. So keys and then max. I think that should work. So now what we can do is we can just do in range n. So for each node, what do we need to know? Well, the first thing is we need to know how many nodes are on tree 1 for our given node. Well, so we just have to get the number of items in the node's partition, right? So so we have x target. So initially, like let's just like say it is 0. So now if it's node even I, so if the ith node is like in the even partition, our max target is just going to add even one. So how many even nodes are in our first tree? Otherwise, well, it will be in our odd partition, right? So we can just do that. And then the second thing we have to do is we want to add whatever is bigger on the other side, right? So yeah, because like remember when we like if we connect to the partition, like to a node like in the partition with less elements, we have access to the other elements, right? So actually like what we can do is we don't even need to do that. We can just do max of odd 2 and even 2. And at the end we can just do answer.append max target. And because we are doing this in order, it will be like exactly what we want there. So I think it should work. Let's see though. Oh no, doesn't. Oh, am I getting the wrong tree? So yeah, so that means like my n is wrong here. Well, that's quite interesting. I guess like what we can do is we can just print out JSON list 1, see what's going on here. So 0 goes to 1, 2, 1 goes to 0, 2 goes to 0, 3, 4, 3 goes to 2, and then 4 goes to 2. Okay. So the first problem is we actually have to add 1 because like the maximum is 4, right? But we actually have 5 nodes. So like this will only loop like from 0 to 3. Okay, the other problem is we actually don't have the correct answer here. So I guess like what we want to do is again we want to print out these to make sure like we are having the correct things. So 5, 3, does that seem right? So like for the 7th, like for the partition of 0, it will be 1, 2, 3, and then odd would be 5. Yeah, okay, so that's correct. That part is correct. So actually for node 3, it is returning. Oh, yeah, actually my algorithm is a bit flawed. So remember like how I said, wait, actually is it? I don't think it is flawed. So 3 can go to 0 and 4, and 3 is in the okay, it might actually be flawed then. Oh. I see the problem. I updated the is no even for the second tree, but it should be only for the first tree. So I think that was the issue. And now, yeah, I'm expecting green now. So unless there are like edge cases, I think it should work. Yep, there we go. And yeah, well, so yeah, let's talk about how I thought of the solution. I think like one of the biggest advantage for this question is that I've read the first part. Because like I remember like yesterday when I read the first part, it took like 5 to 6 minutes like to just like understand what is going on in the question. So like today we don't really have to do that. So that well, actually I'm not explaining my solution anymore. I'm just yapping now. But yeah, I'll talk about how I thought about it. So I think like the first thing I noticed, compared to yesterday's like question, which is like the first part of this, is that our bound is a lot bigger. So we can't afford to do an n squared. We can't afford to have an n squared solution anymore. But another thing that I noticed straight away, which makes me think this question is a lot easier than I thought, is instead of like having to know the depth, like like having depth as the as like the definition of target, we actually have even right now. So what that means is like let's say for 0, like basically what that means is so for yesterday we have to like DFS out to like get the depth, right? But like today I can just partition like based on the depth of the node. And another thing to notice is that like for a tree, every time you move like from one node to a neighbor, you're either moving one depth up or one depth down. So what does that mean? If we move 2 times, actually, what does that mean is for our depth, if we move 1 time, it's going to switch its parity, right? So parity is like odd and even. Maybe I can like use some drawing to explain. So like if we set 0 as depth 0, well, and also like I guess it's important to say for a tree, whatever node you pick as the root, you can always still form a tree. So that's just one property of the tree. So yeah, so let's say we start from depth 6. If we have a depth of 2, and if we move 2 times, well, what could the depth become? Well, it can either, well, maybe let's not use this graph. So if we have a depth 2 node, and if we move 2 times, it's either going to go to 0, 2, or 4, right? So actually, if we move 2 times from, like, if we move 2 times, our parity of the depth, so whether it is odd or even, is going to remain the same. So I think like once you get that idea, the question becomes a lot simpler. Yeah, because like what that means is once you have like partitioned the nodes, you basically know that every node in the same partition is a target of each other, like inside that partition. Well, how do I know that? Well, because like again, every time we move 2 times, we're going to get to, well, like the same parity depth, right? And well, because we have moved 2 times, our length is going to be even, right? So this is like exactly what they want here. Like they want the number of edges, so that the length to be even, basically. So because they're basically the same thing, I can just do the partition here. Another thing to know is that well, like obviously we can partition this again, but it doesn't, like, another thing you have to notice it is the fact that it doesn't really matter which node you point towards if they're in the same partition. So because like if I point to 0, it's the same as pointing to 4, right? Because they're in the same partition. And for all the nodes that are targets of 4, it's going to be targets of 0 by the same logic, like of the even and odd partition and like the depth thing here. But we actually want the larger partition because we want to maximize our number of targets, right? So, well, what do we do? Because like linking to the second tree, well, it takes like one length, right? So that means if we go to any node with the smaller partition, we have access to all the nodes in the larger partition. So, well, what does that mean? Well, we have access to a larger partition, like, long story short. And So that's why I did the whole like the whole partition thing for both um like the first tree and the second tree, and also why it is like it looks quite simple too. Like so we just have to get the right partition on the first tree, and here we actually don't even care about which partition we choose. Like we just want to get the max of it because like we definitely have access to a larger partition. Yeah. So I think that should be it. So if you have any comments or any questions or like even any stuff you want me to explain further, make sure to comment below. And also, I'm pretty close to 100 subscribers, so I'm planning to do something. I'm planning to do a special video, and I think as of now, I'm thinking of doing a video on how I solve LeetCode questions. But if you guys have any like other ideas, so like, I can talk about some data structures and talk about some algorithms, or well, basically like anything interesting. But I think like for my viewers, like you guys probably want to, well, you guys are probably aiming to like solve LeetCode questions faster and like more accurately and be able to like think of solutions quicker and so on. So I think like the like how I solve LeetCode question kind of idea would be better for now. But I'm all ears. Or well, I can also do like multiple videos. So yeah, make sure to comment below. Thanks for watching, and I'll see you tomorrow. Bye.